So hello guys, today's LeetCode problem is a house robber 4. So basically this is the same problem that we have solved yesterday. If you have solved the yesterday's LeetCode POTD, okay, trust me, it is going to be the same level of kind of the problem and the same approach to solve this problem. Okay, so let's understand what the problem is saying us. There are several consecutive houses, okay, given that there are several consecutive houses along a street, each of which has some money inside, okay, and this is the fourth problem for the house robber hierarchy. We have seen the three kind of the same problem, but each of the problem is solved with different approaches. There is also a robber, a thief, who wants to steal the money from the homes but refuses to steal from the adjacent home, and this is the same constraint given from the day one for the house robber hierarchy. Like house robber 1, 2, 3 had a same constraint given there. We can't steal from the adjacent homes. So this is one thing that we have to keep in mind, ki no adjacent homes. This is something that we have to make sure not to steal. The capability of the robber is a maximum amount of the money he steals from the one house of all houses he robs. What does this mean? For example, given me the houses, okay, for example, given me the houses like this, 7, 11, 15 and 19 for example, and he can rob the alternative houses. For example, thief rob this house, then he can't rob this, so he rob this, he can't rob this. So how many houses he has robbed? 7, 15, and the capability is a maximum amount of the money he has robbed from the any of the house. That would be the 15 here, because 15 is the maximum, right? That is the capability of the thief basically. You are given an integer array nums, okay, we are given an integer array nums representing the how much money is still in each house. So that is representing the house money basically, okay. And also you are given an integer array integer k, okay, this is very important, that is representing the minimum number of houses robber will steal from. So it is given we have to steal at least from the k houses. It is always possible to steal, okay, that is also given, it is always possible to steal at least k houses. Return the minimum capability of the robber out of all possible ways to steal at least k houses in the given array. So what is it means? Basically we have given here the nums 2, 3, 5, 9 and k as a 2. So what are the possible choices for the robber to steal at least k houses from the given array? So 2, 3, 5, 9, right? So 2 is given, 3 is given, 5 is given, 9 is given. Makes sense? He has to steal at least k. So we will go for at least k only. So what is a possible way? He will steal either 2, 5. He can steal 2, 9. Right? He can steal 3, 9. So these are only the 3 ways to steal at least 2 houses. And what is given that we have to return what is the maximum, what is the capability of robber from here? That is a 5. What is the capability from here? That is a 9. What is the capability from that is a 9. Because that is given to us. Okay, the capability of robber is a maximum amount of money he steals from the houses, one of the houses. And what is given to us? We have to return the minimum capability of the robber out of all possible way. Minimum. So what is the minimum out of this? Minimum is a 5. So 5 is our answer. That is what is given to us. And this is what we have to find. Okay, this is what we have to find. Let's try to understand with a simple another example that is given to us, test case. What is given to us? Again 2 here. So what is possible? I can steal 2, 9, 2, 3, 2, 1. That is 1. Other way is other would be the 7, 3, 7, 1, right? Other would be the 9, 1. This is all maximum possible ways for it, right? So 1, 2, 3, 4, 5, 6. So 6 way 7, 3 would there, 7, 1 would there, 2, 9, 2, 3, 2, 1, right? And other way would be the 2, 9, 1. So 3 at least steal k, at least he can rob, but more than also he can rob. So what is the capability from here? 9. What is capability from here? That is a 3. From here 2, from here 7, from here 7, from here 9, and from here again 9. And we have to return minimum of this. This minimum of this is a 2 only, right? So this is what we have to solve. So let's try to understand this problem with this example only, 2, 3, 5, 9. Okay, I will try to explain with that only. So given us that I have given here the 2 3 5 9. So I will just write here 2 3 5 9. Okay, this is my given array to me, and again given to me is that k equal to 2. What is indexing? 0 1 2 3, and we have to find the minimum capability out of all possible ways. So if something is asked minimum, so what, at what cost or what minimum money can I rob? That would be the 1, right? 1 money I can rob, correct? Because here given that num of I is containing minimum as 1, so 1 I can rob. Makes sense? Because k is also given that k always is greater than equal to 1, so k can't be 0. That is given, so we can't take minimum at 0 over here. Now what is the maximum you can take? Maximum money you can rob is the maximum of this array, right? And this was the same intuition of the yesterday's problem, right? So what is that? That is a 9. So I have now fixed range of my answer. So I am 100% sure that my answer is gonna lie in this range only. That is given to me. So again, same, whenever you have the fixed range and whenever you have to find the answer, minimum possible answer from this fixed range who is following the constraint, the best way is only and only is a binary search, right? Binary search. So we will try to use binary search over here. Now we have the low, we have the high, we can use a binary search with a constraint given to us. What is my low initially? Low is 1. What is my high? High is 9. And I will have here the each possible function who will return me the true if it is possible to rob that houses with a at least stealing the k houses, at least, correct? So I have the each possible function here, right? Each possible function who will return me the true or false. Who will return me the true or false. What is my high? 9. Low is 1. So my mid would be, in this scenario, at first case, my mid is 9 plus 1 by 2, that is 5. So basically, is it possible to achieve the minimum capability 5 with stealing 2 houses? Correct? Let's see. Let's see now. What is given? 2 3 5 9. I will just put it here. 2 3 5 9. 0 1 2 3. I have to keep my 5 as a minimum capability. So individual capability should maximum only 5. So I have to steal the houses whose many is less than 5. So yeah, I can steal this. So yeah, I steal this. I can't steal this because consecutive houses stealing is not possible. Can I steal this? Yeah, I can steal this. So can I steal this? No. So what is, how many houses I can steal? That is a 2. What is given? K. K is also given 2. So yeah, it is possible. So if condition is becoming true, it means I will update my answer variable. My answer would be minimum of answer comma mid. So that would be nothing but 5 now, as of now. So I will just keep here my answer variable equal to 5. And now I will try to shrink my range. Whenever it is possible, I will try to shrink because I want to find minimum. So my low is again 1 and my high would be mid minus 1. That would be, what is the mid? Mid was 5. 5 minus 1, 4. So again, my now new mid, updated mid would be the 5 by 2. That is a 2. So I will try to rob the houses whose individual capability would be at most 2, and I should able to rob at least k houses. So let's try with 2 now. So given that, so I will just rob, I will erase this part. 3 is here, right? So yeah, is this possible to rob this? Yeah, it is possible. Is it possible to rob? No, consecutive it is. Is it possible? No, because it is a 5. If I rob this, so my minimum capability individual will become 5. So it is not possible. We want to keep it as 2 only. So no. Is it possible to rob this? No. So I can rob only one house. But what is given? I have to rob at least k. So my k is here given as a 2 only. So I can't rob this. So it is not possible. So this function will return me the false. So if it is returning false, I will try to go at a upper range. So I will update my low equal to mid plus 1. What was my mid? Mid was 2. So it will be 3. High again will be 4. What is my new mid now? 3 plus 4 by 2, that is a 7 by 2, that is again 3. So now I will try for 3. Okay, I will try for 3 now. Now tell me, if 3, is it possible to rob? Yes. Is it possible to rob this? No, it is a consecutive. Is it possible? No, because I want to keep maximum 3. Is it possible? No. So again for 3, it is not possible because I am getting only one house. But K is a 2. So no. So I will not update my answer over here. I will go to the 4th step, that will be the go to the upper range. So 3 plus 1, that is a 4. My high is 4. Right? High is also 4. Now my new mid will be becoming the 4 only, because 4 plus 4, 8. 8 by 2, that is a 4. Now I will try for 4. So with 4, okay, with 4, is it possible to steal this? Yes. Is it possible? No. Consecutive is not possible. Is it possible? No. Is it possible? No. So again, for 4 also it is becoming false. So I will try to go to the upper range. So my low will become now 5. My high is 4. So whenever I am achieving this, my low is going beyond the high, I will stop my iteration. Whatever is my answer variable containing, that is my answer, final answer. So this is how you can solve this. And if you remember, this was the same intuition for the yesterday's problem only. And again, one more thing to clear out. If given mid equal to 3, okay, I am trying to take this initially, not this directly. So think, for example, think you have the 4 places. You have to pick up which is minimum, the place which is coming early, just pick up that. That grid approach would work here. Why I am saying this? Let's understand. These are the 4 places. If I didn't pick up this, if I pick up this, so next pickup will happen only after these points. But if I pick up this, my next pickup will happen only after these points. So you can see this one extra place in the grid approach would always work. That's why try to pick up whoever coming up first, pick up that point or pick up that money basically. That is the intention behind the picking up, because otherwise you have 2 choices, right? Pick up or non-pick up. So DP problem also you can think of DP as well, but no, DP will increase your time complexity. Of course it will give the answer, but it will increase your time complexity, and which will not fit in big of n log n time complexity. That's why grid is going to work over here. So that's why I explain you this point, because grid is going to help you here only. Why I am saying is, for example, you want to pick up money as a 5, right, at max. For example, here is 1, here is 2, here is 3, here is 7, correct? If I try, don't pick up this, if I pick up this, so only I can pick up is a 2 max. But if I pick up this, so it will be 1 in my answer. If I can pick up this, so it will be 3. So I can pick up at most 2, but here in this case I can pick up only 1. So that's why the greedy approach would always work here to pick up the first money which is coming up early in the array from left to right. So code for this problem is similar. Okay, before showing this code, let me show you the yesterday's problem code. What was the yesterday's problem code? It was a similar problem. Given here the one function, we were using the same binary search over here and the each possible function over here. And today's problem is just kind of the same only. If you see, this is the main given function over here. This is the main function, right? I am using the binary search over here, and again I am having the each possible. Only the change is that if I am picking up the any element, right, I am increasing the count, I am jumping to the next index, because I can't pick up the adjacent indexes, right? If I pick up this, I have to jump here, that is a index plus 2, or else I can't pick up this, I will just go to here, that is index plus 1. That is what I am doing here, and I am checking if I can rob at least k houses that is greater than equal to 1, I am returning the true. And this is what something I am doing here. So if you see, my while loop is going from low is less than equal to high, right? Initially low is 1, high is maximum of nums. If it is possible, then update my answer, shrink my range, or else go to the upper range and return the answer. So time complexity this problem would be the big O of n log n, because the log n for the binary search and n for the iterations for the array for the each possible function, and the space complexity would be big O of 1 only. So I hope you understand this problem. See you in the next video. Thank you.